Now let's look at how character arrays match up with strings, or maybe they don't match up with strings. So let's compare character arrays and see what they can do, and let's look at our string type and see what kind of things it can do, and even more than that, when can we do things together? When can we concatenate them together? And when can we treat strings as characters and maybe treat characters as strings? Anyway, there's a good bit of detail here. There are some important things to remember. So I'm going to go through this kind of carefully and just look at some examples of things that we can do. We need to start by declaring variables, pretty much the way we start everything. So I've got some variables declared. I've just got a simple character ch4 that's an uppercase A, but I've got a string here. I've got string, one letter. It's declared as a lowercase a, but notice that I'm using the double quotes instead of the single quotes. I've got a single one word string called bird. It's initialized to bird, and there's a space before it for some reason. And I've got a string line, which has just 4 of our 4-letter words from the dictionary in there. Now, before we get into some of the other parts down below, let's just take a look at the difference between this character uppercase A and this string, which is a lowercase a. Those are different types, and how are they really different? Well, the character A, ch4, that is, containing the character A, that just contains the ASCII code for an uppercase A. And if we put a comment in here, then this means that the character ch4, which is only 1 byte, it contains the number 65, which is the character code for an uppercase A, the ASCII code for that. Now, the string, 1 letter, which contains the A with double quotes, it actually has 2 bytes of storage that are required. It takes 2 bytes to store that. And the reason is that when you have a string, there's always the \0 that is appended to it on the right. So we have, in the case of the string 1 letter, we have 1 byte for the lowercase a, which the ASCII code is 97. Then, even though you can't see it, there's a \0 that's always appended, and that takes a byte as well. So it takes 2 bytes to store just a single character. And in the case of every other string, there's a \0 character that's always included in there. Same thing down here with the string line. There's a \0 included. So that's the real big difference then between what a character is and what a string is. A string will always have the \0 appended to it on the right. Now let's look at the other variables that I'm going to use in this example. I'm going to use the alphabet character array again, but this time I'm going to initialize everything to 0. And you can do that the same way you would initialize an array of integers or floats to zeros. So this will initialize every character in the array alphabet to 0. And since we know that the code for the \0 is 0, that means that there won't be any extra garbage printed out when we print out the array alphabet. I've got this array again. Letters is in here. I'm not sure I'm going to use it, but it's kind of a holdover from the previous example. And this time I've got a one-dimensional array that is a string type. So in this case, it is a one-dimensional array, and it has 5 as the number of items it can contain, and I've initialized it to just those 5 words that you see there. Now, I'm going to slip in a 2-dimensional array here, and we'll get to that near the end of this example. But this is a 2-dimensional array called items. It is a character array, and as you can see, we can store multiple words in it as well. So we'll look at how these differ once we get near the end of this video. All right, now I've just got a bunch of examples that I want to show you. So I'm going to kind of quickly go through these. And the questions show up here as strings. First, can you concatenate a string onto another string? Yes, you certainly can. And then we'll go through some of these others as well. So let's add code for each one of these questions as we go through. All right, so let's do the first one. So let's paste an example line of code here that does concatenate strings. So I'm going to take the string line and I'm going to add on to it the string one word. Well, let's see. Line contains those 4 words, and if I'm going to concatenate one word onto that, then I'll add on the word bird to that. All right, then we'll print out the value for line. Okay, but I'm going to do several of these before we compile and run the program. The next question is, can you concatenate a one-letter string onto another string? So we're going to concatenate that onto the line as well. So let's put the line of code here to do that. So we'll paste that in. And in this case, we are going to add on to line our string, which is one letter. Okay, the one letter variable, that was just the lowercase a up here. So we've got a single letter that's a string, and we have line, which is a string, and we can indeed concatenate those together because they are both strings. What about different types? Can you concatenate a character onto a string? Okay, so that's going to be our case number C. So let's put a line of code there to test to see if that works. So I'll paste the line here. So in this case, I'm still using the variable line, which is a string, but I'm going to concatenate it with, we'll concatenate a character, ch4, so we know that that's the character type up here, which is an uppercase A. All right, so will that work? We have, by the way, plus is the concatenation operator that I'm using here. So now I have added several things onto line, and then we'll print those out. Okay, let's stop at this point and let's see if those 3 cases work. And I'm going to insert a system pause right there to stop the program, and we won't see all the other output that we have. So I've added in the system pause, and that means we won't get the output from all the other stuff that's further down. So let's compile this and run it. Now we have the output screen, so let's bring this over. And let's just kind of, I think I can fit it in on the side over here so we can just go down through each line. All right, so we print out examples, so you see that, and I print out the string here, one letter. Okay, so one letter just prints out the one letter, which was a lowercase a. And then we've got a cout statement that prints out our character type, ch4. So we see that showing up here as the uppercase A. Now we go down through cases A, B, and C. So in case number A, we took the line string type and the one word string type. We did a concatenation and we print those out, and sure enough the bird shows up here. So we can concatenate 2 strings. Okay, in the next one, in B, we just want to concatenate the letter, one letter, which is a string, because that's the double quote A double quote. So one letter is a string, line's a string. So in case number B, yes, we can concatenate the letter A here onto the other string line. Okay, so that works just fine. And then in case number C, here we are going to concatenate a character type onto line and print that out, and that works too. So you can concatenate a character onto a string, as we have shown in example number 3. Let's continue with the other examples. Can you, let's see, can you put a character into a slot in a character array? Okay, so I'm going to do something with alphabet here. First of all, let's move our system pause down here so it's out of the way. And we'll do examples D and E. Can you put a character into a slot of a character array? Well, I certainly hope so. Let's put the line of code in here to do that. So we drop that in. And in this case, I'm using alphabet, and I'm going to store into index 5 the value that's in our character variable ch4, and that was just our uppercase A, remember. Then we'll print that out. Now let's go ahead and do the other one as well. Okay, can you treat a string as a character array? All right, so let's do something to that. Let's add a line of code here to see if we can do. So here's the example line, and we're just going to take line. Now line is a string. I'm going to use the square brackets and index number 5 like I did with the character array up here with alphabet. So I'm going to treat this string temporarily. I'm going to treat it as a string of characters, and I'm going to store the uppercase A into location number 5, and then I'll print that out. Well, I'm going to give away the end here. All of those work, so you can do that. But the following things do not work. I'm going to move the system pause again out of the way. Let's put it down here, and I'll talk about these operations. So let's clean this up a little bit. And I'm going to take away the comment here. So I'm going to get an error. So I'm trying to put the one letter variable into the alphabet, which is a character array. One letter is a string. Okay, so one letter up here that contained the string A, and remember, it takes 2 bytes to do that. It takes 2 bytes to store that because of the \0. So for that reason, it will not fit. One letter here, that variable, is actually 2 bytes long, and 2 bytes will not fit into 1 byte. So you cannot do that. So that's not allowed. Well, how about the other thing here? Let's take the comment away. Can we concatenate a string onto a character array? Apparently not, because we have the underscore that's in red. So I've got a character array, and I'm trying to concatenate onto the character array this string called one letter. And no, you cannot do that. And you cannot use the concatenation operator with a character array. You cannot extend it by using this concatenation operator. So let's put the comments back there, and let's uncomment this last one. And this is sort of the same thing. Okay, up here we're trying to concatenate a string onto the character array, and that didn't work. But what if we just have a single character like Z? So if I try to do that, that doesn't work either. And even though there's space for it, the character array alphabet cannot be extended by using a concatenation operator. So that's not allowed either. So that tells you already that the string variables have a lot more flexibility than the character arrays do. Well, let's compile and run the program so we can see the result from the D and the E cases up here. We have the results, so let's bring that over. So for D and E, I'm printing out alphabet in example D, and let's see, what am I printing out here? Well, I didn't see anything, and I'll tell you why. D is blank right now, and I'll come back to that. So let's look at E next. Let's take line index number 5, and we put ch4 into it. So here is line printed out. So here's shop. So that's 0, 1, 2, 3, 4. So at index 5 now we have the uppercase A. So you really can then treat a string as a character array, and then you can just insert characters wherever you like. The reason we didn't get anything here is that when I initialize the alphabet array, and let's go up here and take a look at that. When I initialized alphabet, I put all zeros in there. So I inserted the character ch4 here at 5, but there are a bunch of zeros prior to that. So if I want to see it, then I've got to put it over here at index 0, not at index 5. So let's change that up and run it again. Now we have the output again. So now we will have something in the alphabet array D. So case number D, then I change that index from 5 to 0, so we can see the first character that pops up, which is in the, well, that's the wrong one. We can see that the A pops up this time. So by changing the index to 0, I can insert the character variable ch4 into that character array. So yeah, you can do that. You can insert a character into a character array, certainly. All right, so that illustrates then all of these cases, and we just talked about these cases here which are not allowed. So make sure that you understand what's going on there. Before we get into all the cases that are shown below with those red output statements, I want to show you how you can compare strings. Now with the character arrays, we had to use string compare. But if you have string types, then you can compare them the same way you compare numbers. So here is an example. One word is a string, line is a string. So you have the comparison the relational operators that you can use with the numbers, and you can use them here with strings. So you can use the less than operator, you can use the greater than, you can use the equals, and you can compare strings, and you don't have to use that strcmp function that you have to use with strings, with character arrays. So that's one advantage. And in addition to comparing them as just less than, greater than, or equal, you can also use the combined relational operators and make other comparisons as well. For example, if I put this code in, then we can also compare with the other relational operators, greater than or equal, less than or equal, not equal. So here's just an example of that. We can do two strings, less than or equal, greater than or equal, or not equal. So all of those relational operators work with string types. So that's another advantage of using strings whenever you can. You don't have to worry about bringing up some function like string compare. Plus, you got the additional ability to use these other relational tests in as well. Now, to prove this, I think we should compile and run the program. Now we have the results. And if we look at the comparisons down here, we are comparing, and what were we comparing? We were comparing one word with line. Okay, one word was just the word bird, and line is that line with several words on it. So one word is certainly less than line, so it shows up here. Bird is less than, and here line contains all that information. So you can see the comparisons work. And in addition to that, if we look at the less than or equal to, then that is equal to, it's less than, so we also get an output there as well. So we will see that bird is less than or equal to line, which is this stuff here. All right, so we get those two outputs, and once again, it's really easy to compare strings. You just use your normal relational operators. Okay, so now let's move on, and let's look at case number 1 down here. All right, so this was a trivial case. How do you output a string? It's almost not worth doing. We just do a cout with line, and we can print it out. Let's move our system pause down again, so we won't stop and compile and run case 1 since it's so trivial. But case number 2, let's output the string as a character array. All right, so that's a little bit different. We're going to use this string line, and we're going to print it out. So let's get a loop that will do that. So this little for loop will work nicely. And one thing we have to do here is we certainly want to start at the 0 index, and we want to index into the line using the square brackets and the index k, but we don't really know how long the line is. So we can take advantage of the length function that you can apply to a string, and we can find out how many characters there are in that string line. And then k will go up to 1 less than that. So k goes from 0 to the length minus 1, and then we just print out all of those characters. Okay, now in this case, I don't have an end line over here, so I'm going to print these all out one after the other, and then after we exit the loop, then we'll print the end lines out here. Okay, now I think we can go ahead and compile and run the program to see what case 2 looks like. Now we have the output. Come over here. There we go. So case number 2, we are going to output the string as a character array. So this for loop right there, it did print out everything that was in line. It just printed them one character at a time. So the main point here is that you can index into a string using the square brackets and an index if you want to. Now the system pause was down below case 3, so that's why you see this output here. Now let's go look at case number 3. Output the words in the string array words. Well, I suppose I should have done that before I compiled it, because that's pretty easy to do as well. We just have a single array words, and it's a string type, and it has several words in it. We want to print those out. So that's easy to do with a little loop, and this loop will work well. So we just have 5 words in our array. Go back up and take a look at it. Okay, so we have string words, and the words were initialized to those words. So now we will just print them out. So if we go back down and print out that particular case, then we just have a nice little for loop that will go through indices 0 through 4, and it prints out all the words. So nothing much there. It's pretty easy. Hopefully that's straightforward. Let's do something else before I compile and run it. I want to enter some new words, and then I want to print those out. All right. So let's move our system pause down to just before case 4, and let's add the code in so that we can type in some different words for the array words. So let's get a loop to do that. This little loop will do fine. And we're again going with K. K goes from 0 up to 4. And I've just got a little prompt in here. We want to enter the word that goes to the screen. And since we have the 5 words, I'm going to say enter word 1, enter word 2, and so on. So that's why the K plus 1 is there. Then just a colon, and then we'll have the word typed in on the same line. And then we'll just use CN, and we'll read the new word that we type in directly into the array. Then we want to output those new words. So we can do the same thing that we did up there. So we can just copy that for loop. We can drop it in here, and we can print out the new words. So this is going to illustrate how we can enter new words for our one-dimensional array for the string type words and then print those out again. Again, there's nothing magic here. This is pretty trivial, but it's important. So let's compile and run the program. Now let's bring over our output window. And we have just printed out the words that are in the string array, and we printed them out one per line. Okay, so that's what you see from here, case number 3. So we print out mouse, train, book, encyclopedia, and anvil. Now we are in the loop where we are being prompted to enter 5 new words. So I'm going to type in some new words that will go in the array. Okay, so these are really ingenious words here. Let's do cat, and let's do cow, and moose, and let's do owl, and let's just do tank. Okay, so whatever you want to type in, right? So I've entered in 5 new words. Those are going to go into our array called words. Then I will print those out. And here they are, cat, cow, moose, owl, and tank. All right, so nothing really magic going on. We just changed the words in the array. Now, let's move on and let's look at our character array. If we go back to the top and we consider the character array that we had, then it was called items. And this character array has 2 dimensions to it. And this works perfectly well. But notice that we have a 2-dimensional array that we have to consider. The items that we have for the first set of brackets, we have 4 things. And each of those is a word. So it's okay to do that, okay? So the first word can have up to 10 characters, so we can put eggs in it. Okay? The second one would be index 1, so milk would go in there. And again, it can be up to 10 because each one of these can be 10. And then we just go ahead and we put toast in for index 2 and ice cream for index 3. So you can store words into a character array as long as you declare it to be 2-dimensional. So this says we have 4 words and each word can have a maximum of 10 characters. Let's print out that information. Let's reset it with some different words and print it out again, just like we did with the string array. So let's scroll back down and let's do something very similar here. First of all, we want case number 4. We want to output the words in the character array. Let's move the system pause down to right before case number 5, and let's add the code in to print out the words in the character array. So this is really similar to what we just did. We can use a for loop, and within this I can use just a single bracket and print out all the words. So that's what I'm trying to get at here. All right? In some cases, you have to use the 2 sets of square brackets, and in others you don't. But, you saw from our previous video that you can print out an entire character array just with the cout statement. So in this case, I've got a character array that has 4 words in it. Each one of those words is 10 characters, but I don't have to use that second set of brackets in order to print out those words. So it will print them out just fine. Now, before we compile and run it, let's enter some new words for the character array items. And I'm leaving this notation here to indicate that it is a 2-dimensional character array. So let's put the code in to enter new words for the array. So here's some code that will work. It's another for loop, and it's pretty much identical to what we did with the array of strings, words. But this time, we are going to use items. So we're treating it very similar to what we did with the array. The only difference is I only have 4 items in the array items, and I had 5 in the array words. So this lets us type in some additional words or some words to replace the ones that were there to begin with. Then we will output the new words. So we're repeating the same thing we did with the string. So I'm going to get the statement, the C++ code to put in here to output now our words, and I've already got that, right? So we can just copy the for loop up above, and we can paste it here, and then we can print out our new words. Then we'll move on to the other cases, but let's try this one first. We want to see how this 2-dimensional character array behaves. So let's compile and run the program. Let's bring over the output. And I went ahead and typed in the words for the replacement of the words string array. And now we're at case number 4. So we print out the original words that are in the items array. So we had eggs, milk, toast, and we had ice cream. So we had those 4. Okay, now we're in a loop and we want to replace those with some new words. Okay, so let's type those in. I want to keep those short for a specific reason I'm going to bring up. I'm going to put the word at and the word be. Then I'm going to put in, say, cat here and owl at the bottom. So those words that I'm typing in are all shorter than the words that were in there to begin with. Then when I hit enter, then we will print those new words out. So we have at, be, cat, owl. All right, so now that really isn't a surprise either. But what I want to show you next is that there are still some extra characters in here. Okay, so I've got the AT and I've got the OWL, but if you look at the original words in the array that we started with, some of those letters are still in there. They did not get erased. So this next set of examples will show you that. So I'm going to put a loop here that is going to print out the data that's in the 2-dimensional array items. Okay, let's move the system pause down. In fact, I'm going to delete it altogether because we're at the end anyway. Okay, so I'm just going to delete that. And we'll have case 6, but we'll worry about case 6 when we get there. I'm going to treat the array items this time as a 2-dimensional array, and I'm going to print them out character by character. So this internal loop is going to go from 0 up to 9 because items has 10 possible spaces here, or it has a dimension of 10 for each word. So the J loop that I have here is going to go from 1 to 10. So we will print out all 10 characters that are in the array items. The outside loop K is just going to go over each of the words that we have. So if when K is equal to 0, then we will print out the indices 0 through 9 for index K being 0. So that will print out everything. When I did print this out up here, then I didn't get all 10 columns out of items. I just got the ones where the new words were stored, just the new words, not the whole thing. This will give us all 10 columns, and let's compare them. All right, now let's go ahead and compile and run the program, then we'll come back and do that last one. Okay, let's bring over the output. And I'm down to case number 4 here. So we want to output the words in the character array items. Okay, so here they are: eggs, milk, toast, and ice cream. Then I'm going to type in the new words again. So I'll type in at and bee and owl. And let's put in something else here. Let's put in just a cow. All right. So those are 4 short words. Then I print those back out. And when I printed them with this loop up here, then I didn't get any extra letters. But when I print them out with case number 5 with the doubly nested for loop, then I get some extra information. So let's look at that. So from the single nested for loop, we just get the new words: at, bee, owl, and cow. But look at case 5. When I print out from case 5, I get AT and S. So I did enter the AT, then there's a space, and then there's an S. So that's because I replaced eggs with at. Okay, so I get the AT replaces the EG, and then there's a space that's put in here that takes out that G, but the S is still left. It's still in there. So that's why we have the S here. And the same thing for the other ones. Okay, at the bottom we have ice cream. Then for word number 4, I put in cow. Right? So cow cream now is printed out. So cow replaced the ice here. Then we had the space, and that space came along as part of the input here with cow. But the word cream was still left over in the array. This illustrates something even further with strings. In the case of these character arrays, then you need to be really careful about how you're using them, because there could be some leftover information that you don't want. So if I were to do this and I only wanted to have the words at, bee, owl, and cow in there, then I would need to reinitialize the array here before I put the new words into it. I need to set all of those items to 0 or to blank before proceeding. In the case of strings, you don't have to do that. Okay, strings are not going to give you any extraneous characters because they resize themselves each time you change the words. So this double nested loop then shows you all the characters that are in the items character array. Now, the last thing I want to show you is that we can treat the array words as a 2-dimensional character array. It's kind of the reverse of this. Okay, our 2-dimensional character array, we could treat it as a single-dimensioned array and print out each word, or we could print it out 1 character at a time, as we did in case 5. But we can also take case 6. We will take the words array, and we will print it out the same way we did with the items array. So let's put the code in to do that. So we can put the code here, and it's almost identical to case 5. In this example, we have 5 words in the words array, and I don't know the length though. Okay, with the character array, I knew it was 10. This is a big deal. Okay, I'm having to use the length of each word for the inside loop. So J is going to be going from J up to the length that is it's less than 1, so it's a less than sign. So I get the length of each one. How would I do it otherwise? Well, let's look at the words. Okay, originally, I know we changed them, but if we look at the original array, then the length of the words is different for each one of these. Okay, mouse is 5, and train is 5, book is 4, encyclopedia, we have a lot of letters there, and then we have anvil. So the length of the words that we have in our string array for words changes. So I could guess at how to print out this, how many letters are there. Well, I could assume that maybe that's the longest one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's like 12 letters. And if I go to the bottom again, then I could guess that this internal loop that I'm using, this J loop in here, I could assume that that would be 12. Okay, so if I put 12 there, that would only work for encyclopedia. It wouldn't work for the other ones. So when you have a string type, as we do with words, you can put different length strings into each one. And if you need to know how long each one is, then you have to use the length operator or method in order to get the length. And then that allows you to set the limits for the j variable inside this internal loop. So that's the only real difference here. In a string array, we have to check the length of each word, whereas in our character array, we know it's 10, it's always 10, it's never going to change from 10 unless we recode the program. So we can do this here. We can print out each of the characters in our string array, treating them as a two-dimensional character array, but we have to be careful about the length. If we don't do that, then the j index will go out of bounds and the program will abort. Now, let's compile and run this last example. Let's bring the output over. So now you can see that the output from our 2D character array, words, is printed out to the screen. Okay, so I entered those values in up here, somewhere up here. Okay, so where we had the example where we had to enter new words for the array words, then I entered these words, cat and mussel, dictionary, owl, and bee. So those are printed out down here using our two-dimensional doubly nested for loop. So that worked just fine as well. So this gives you then some comparisons between string arrays and character arrays, and some things you can do with them, some things you should be aware of, and some of the things you can't do with them. That concludes this video, finally. So let's stop here and let's go take a break.